Hi everybody, this is your notes video on properties of triangles. Now, I have all of these theorems and drawings already done for you. I'm going to do a couple of examples using each theorem. A lot of these rules you probably already know because we've either talked about them this year or you may have seen them in previous years, but then there may be one or two that are new to you. Okay, so let's go ahead and jump in here. So first theorem that we're going to talk about is the triangle sum theorem, which is exactly what it sounds like, right? That all three angles in any triangle add up to 180 degrees, okay? It's true for any triangle, whether it's an acute triangle, a right triangle, obtuse, scalene, isosceles, equilateral, doesn't matter. All three angles have to add up to 180 degrees every single time. Now I have this drawing for you here, which kind of shows why that happens, right? I have this triangle with these three angles, 1, 2, and 3. When you kind of tear off the three corners, right? 1, 2, and 3, and line them up next to each other so that the vertices of the angles are touching. See how they form this straight line down here at the bottom, right? Which, remember, has 180 degrees in it, right? All straight lines have 180 degrees in them. Okay. All right, so let's take a look at these examples, right? So here they want me to find x and all of my angles. So I know that all three of these angles here have to add up to 180 degrees. So I'm going to add all three of my angles. So I have x plus 40 plus 3x minus 17 plus 2x minus 5. Let me make that text a little bit smaller there. I'm going to run out of space. Let's try that. There we go. So all of that together has to equal 180, okay? So I'm going to combine my like terms. So I have x plus 3x plus 2x, which is 6x, okay? And then I have 40 minus 17, which is 23, minus 5 is 18. So 6x plus 18 equals 180, okay? And then I have to subtract 18 from both sides. Right, so I'm going to do minus 18, okay, so I end up with 6x equals 162, and then I'm going to divide by 6 on both sides. Okay, so I end up with x equals 27. Okay, so if x is equal to 27, then that means this angle here has to be 67, right? 27 plus 40 is 67. Okay, then this angle here, 27 times 2 is 54, minus 5 is 49. Okay, and then for my last angle, I could either plug 27 in, 3 times 27 minus 17, right? Or I could say, well, 67 plus 49 plus my missing angle has to equal 180. So I'm going to do it that way just because it's a little bit simpler. It's a little bit less multiplying for me to do. So 67 plus 49 is 116. So 116 plus the angle that I'm looking for. I'm going to subtract 116 from both sides, so I get 54. Right, when I do that. Nope, sorry. I subtracted that incorrectly. Should be 64. 64. Apologies, everyone. Okay? So that angle there is 64. And you can verify it if you multiply through this way. Okay? All right. So then okay, so if we take a look at example number 2, right, I'm trying to find this angle here. Okay, there's a lot of information here, but there's also lots of different triangles in here, and they give me some information that I don't really need, right? Like I have this 65, this 90-degree angle. I don't desperately need that. Okay, and here's why. I have this triangle right here, right? If I can figure out what this angle is, the one that I have the question mark on, and then subtract that from 180 because the question mark angle and the x angle that I'm looking for form a straight line, which has 180 degrees in it. So I think if I can figure out what that question mark angle is, then I can subtract that from 180 and it'll give me my x angle. Okay, so I have 50 plus 80 plus my question mark has to equal 180. Okay, so this is 130. So my missing angle, my question mark angle is 50 degrees. Okay, so that means that 50 plus x has to equal 180. And I subtract 50 from both sides and I get that x is equal to 130. Now I'm hoping that you noticed, wait, 130, didn't that show up here? Yes, it did. Okay, and we're going to get into that in a little bit when we talk about the exterior angle theorem. All right, so give me a second to clear my screen off and we're going to talk about the next property. All right, folks, so here is our second theorem. I don't remember if I mentioned this at the start of this video, but there are 5 big triangle rules, triangle theorems that we have to keep track of and remember. So this is the second one, which is called the angle-side relationship theorem, okay? It has this long written explanation, but basically what it means is that the smallest angle in any triangle is always going to be opposite or across from the smallest side. Okay, same thing for largest side. So here in the drawing, if you see angle B, the one marked in red, is the smallest angle. Okay, and it is across from the shortest side, right? That side marked in red is the shortest side. Okay, similar idea with angle A, right? And side A. Okay, angle A is the biggest angle, the one marked in blue, and the longest side is side A, which is right across from it. Okay, and then obviously, again, same thing goes for the middle side. I have it written incorrectly here, that the smallest angle is C and the shortest side is C. That should have been B. So that will likely be fixed in your version of the notes, but mine is not fixed here because this is a slightly older version. Okay. All right. So let's take a look at these examples here. These are fairly simple. Most of the time, you're just going to be ordering things, like putting things in order. Okay. So here, this says order the sides from smallest to largest. Well, to make sure that I put things in the right order, I need to figure out what this missing angle is. So if you remember from the previous theorem, triangle sum theorem, that I know this angle A, if I add that with angle B, which is 30, and angle C, which is 65, it should give me 180 degrees. So I have angle A plus 95 equals 180. So that means angle A has to be, if I subtract 95 from both sides, has to be 85. Okay, so this missing angle here is 85. Okay, so that means my shortest side is across from B. Okay, so my shortest side, let me change my color so it's a little easier for you to see. The shortest side is this one, AC. Okay, so AC is the smallest side, so that's less than the medium length side is AB, because that's across from the middle angle, okay, which is less than the longest side, which is this one, BC. Okay, and really I should put little line segments over the top of those so that we know we're talking about line segments. Okay, there you go, easy peasy, smallest to largest. Okay, all right. Let's look at example 2, which goes in the opposite order. Okay, so this says list the angles from largest to smallest. So the largest angle is across from the longest side. 26 is the longest side, so Q has to be the biggest angle. Okay, so angle Q is greater than the middle sized angle is across from the medium length side. Okay, so angle Q is greater than angle P, and then obviously the last one is across from the smallest side. Okay, so angle Q is greater than angle P, which is greater than angle R. Now, the reason that I chose this image is because it's a little bit hard to tell just looking at the picture which of those angles is big, like is smallest, really. Angle P and angle R look like they're almost the same length or the same size. Okay, that's why you have to go based off the sides that you have available to you. Okay, remember, nothing in geometry, you can't assume any picture is to scale unless they give you exact numbers or they tell you like certain sides are congruent or certain angles are congruent, things like that, right? Or you're given a right angle, for example, right? You can't take anything for granted. You can only go based off of the information that's explicitly given to you, not necessarily like what the picture looks like, 'cause the picture may not be to scale. Okay, so just be careful about that, especially with things like this, like in this one, because if the triangle is not to scale, then you're going to get the answer wrong if you just go based off the picture rather than the numbers. All right, so we got 3 more theorems. Give me a sec, I got to clear my screen, and then we'll look at the next one. All right, y'all. So here is the third theorem. I'm hoping this is another one that you've seen before, just like the angle side theorem. I'm hoping that you had seen that one before. This one is called the triangle inequality theorem, which basically says in order to make a triangle, in order for 3 side lengths, 3 line segments to come together and make a triangle, the sum of the 2 shortest sides has to be greater than the longest side. Okay, and here's why. Okay, if we look at, say we have a triangle where we have one side is like 12, you have another side that's say 3 and another side that's 5, right? If the side that's 3 units long is here, right? And the side that's like 5 units long is here, okay? These 2 sides are not long enough, even if you like bring them and you pull them down like closer to the long side, and you make them like you try to make this angle at the top as big as possible and these angles at the bottom as small as possible, these 2 sides are never going to touch. They're never going to reach each other. Okay, so the theorem itself says that the sum of the lengths of any 2 sides has to be greater than the length of the third. Really, the best way to go about checking this is if you check the 2 shortest sides against the longest side. Okay, that's the best way to check those things out. Oops, sorry guys, I'm getting messages. Okay, so here you have all of these inequalities, right? But that's essentially just translating the written theorem into math language, right? I'm adding 2 sides and checking to see if it's greater than the third. Okay, so let's take a look at this example right here. This says find the range of values for side S. Okay, so basically what we're going to do is plug these 3 sides, 1, 2, 3. This one I'm going to say is like A, this one's like B, and this one's like C, so that they match my drawing right here. And I'm going to plug them into these inequalities. And solve for S. Okay, because what that will do is it'll give me ranges, right? Like it'll say S has to be greater than a certain value, less than a certain value. Okay, so here we have, and I'm going to write these on this side because I'm running out of space here. So I would have to check 4 plus S. I need that to be greater than 7. Okay, I need 4 plus 7 to be greater than S. And I need, oh, terrible. It's a terrible S. Let's try that again. S plus 7 has to be greater than 4. Okay, now what I want you to notice is that these first 2 inequalities right here, the top 2 would make this one is like if S is the shortest side, Okay, and then this one is if S is the longest side. Okay, this bottom one is if S is the middle side. Okay, and what you're going to see when we do the math and we simplify these is that this one, this middle one, is going to give us something that's not realistic, right? So if I solve this bottom inequality right here for S, if I subtract 7 from both sides, I get S is greater than -3, which has to be true, right? Because side lengths can't be negative, right? So this one, you almost don't need to check, right? So you really just have to check these first two, right? Where you have the shortest, the smaller number plus S or plus your variable is greater than the larger number that's given to you. And then you add, that will give you your like lower bound, right? So if I solve this one for S, I get that S has to be greater than 3. So that's going to give me my lower bound. Okay. And then if I solve this one where S is the longest side, where I just add the two numbers, I get that S has to be, oops, I wrote that backwards. Okay, S has to be less than 11, right? Because that's what this says here, right? 11 is greater than S, S is less than 11. So that gives me my range right there. So 3 is my lower bound. So S has to be greater than 3, but less than 11. Okay, so when you're doing problems like this, you really only need to check these two inequalities right here. Okay, so add the smaller number with S and say that it's greater than the larger number they gave you, and then add the two numbers for the sides they gave you and check to see what value, and then like pretending that S is your longest side. Okay, all right. Second example here. This says which of these lengths can form a triangle. So really all you have to check is, do the two smaller numbers, so the sum of the small numbers, is it greater than the largest number? Okay, so here I have 3 plus 4 is greater than 6, which is true. 7 is greater than 6. So this one works. Check. Okay, I have 5 plus 6, is it greater than 11? What I end up with is 11 is greater than 11. So that one does not work. Okay, it has to be greater than, not greater than or equal to. What would happen with these two is they would meet, but they basically would like stack on top of each other. You'd have two lines that were 11 units long stacked on top of each other. It wouldn't make a triangle. Okay, and then this last one, 2 plus 3, is that greater than 9? And obviously it's not, right? 5 is not greater than 9. So this top one is the only one that works. Okay, all right. So we've got two more theorems to look at in this video. Give me a second, let me clear my screen, and then we'll talk about those last two theorems. All right, folks, so here we are. This is the exterior angle theorem. Okay, so here's what this says. Well, first, let me tell you a little bit about exterior angle. So an exterior angle is exactly what it sounds like. It's what happens if you take a triangle and extend one of the sides, okay, and then you have an angle that is made with one side of the triangle and then the extended side of the triangle, right, that's obviously outside of the triangle. So in this drawing, angle 4 right here is my exterior angle, okay? So the rule for exterior angles is that the exterior angle is equal to the sum of the two remote interior angles. Okay, so remote interior angles are just the two angles in the triangle that are not directly attached, right, or right next to the exterior angle that you're looking at. So for example, angle 2 in this drawing is right next to angle 4. It's attached to angle 4, okay, which means it's not a remote interior angle. It's just a regular interior angle. Okay, so 1 and 3 are my remote interior angles. Now, here's why this is cool and why it matters and why it helps you, okay? The reason that this works is because we have a couple of a couple of combinations of angles here that add up to 180 degrees, right? I have angle 1, angle 2, and angle 3 that all together have to be 180 degrees, right? Because they make a triangle. And I also have angle 2 and angle 4 that come together and are 180 degrees because they are a straight line, which has 180 degrees in it. Okay, so I can set these equations equal to each other by the transitive property, right? If you remember that from when we did proofs. So I have angle 1 plus angle 2 plus angle 3 has to equal angle 2 plus angle 4. And what I can do is subtract or eliminate angle 2 from both sides, right? So what you end up with is angle 1 plus angle 3 equals angle 4. So that's a little proof, right, of why this works. And the reason it's cool is because you don't have to go through and use angle 2, right? If you don't know it, you don't have to solve for it first in order to figure out what the exterior angle is, right? You can bypass it completely and just use the two angles that you do know, which is kind of cool, okay? And that's exactly what we're going to do in this first example right here. Okay, so here I want to find x, which is this angle here. Okay, it's the exterior angle to these two remote interior angles. So all I have to do is say x is equal to 21 plus 34. Okay, so x is 55 degrees. That's it. Okay, you didn't have to go through and find this missing angle first, which is something that we had to do when we did this problem here. Okay, if you remember that, we went through and figured out what this question mark angle was first, and then used that to find x. And we found out, oh, that x was just the same as these two angles added together, right? So it's basically like eliminating a middle step, right? And it's a work smarter, not harder kind of thing, right? Rather than doing a bunch of extra calculation, you can just do it in one step, which is kind of awesome, okay? All right, so let's look at this second example right here. So again, I want to find, it says find x and any missing angles. So I'm going to find x first, and then I'll use that to find my missing angles here. So again, I have this question mark angle that I don't know, but rather than use that to solve for x, I'm going to add these two remote interior angles and set it equal to the exterior angle. So I have 2x plus 3 plus 51 has to equal 100, okay? So I have 2x plus 54 equals 100. I'm going to subtract 54 from both sides. So I end up with 2x equals 46. And then I'm going to divide by 2. Divide by 2. So I end up with x is equal to 23. Okay. All right. So what that means, if x is equal to 23, that means that this angle here, the 2x plus 3 angle, is 23 times 2, which is 46, plus 3, which is 49. So this angle is 49, which makes sense, right? Because 49 plus 51 has to equal 100. Okay, and then now I need to find this one last missing angle, but I know that this plus 100 has to equal 180 because they form a straight line, right? Those two angles form a straight line right there. So that means that my question mark angle is 80 degrees. All right. So it just eliminates some extra, like adding extra numbers that you may not need, right? It's like eliminating a combining like terms type step that you would have to use if you were doing, say, like the triangle sum theorem. Okay. All right, you guys, I've got one more theorem for you about isosceles triangles. So I'm going to pause really quickly, clear my screen, and then we've got one more property for you. All right, folks, so here we are. This is our last theorem, which is for a specific type of triangle. So this is called the isosceles triangle theorem. Okay, so if you remember from middle school, isosceles triangles have two sides that are equal and one side that is different. Okay, those two sides that are equal are called legs. Okay, so you have two legs that are congruent, right? See how in the picture they're marked with the little congruent symbols? Okay, right? So that means congruent. Okay, and then you have the base down here at the bottom, right? You can think of it almost as if the triangle's standing upright, it's like what it sits on. Okay, there are two base angles at the bottom, right, which are literally like the angles that are directly connected to the base, right? They're at the bottom of the triangle. And then your third angle is the called the vertex angle. Okay, so the isosceles triangle theorem states that if a triangle is isosceles, okay, then the base angles are congruent. Okay, so these two angles right here are congruent. Okay, and it goes the other way around as well, right? If I know that the base angles are congruent, that's what the converse is. Converse is basically like a flipped or a backwards version of a theorem. Okay, so if I know that the base angles are congruent, then that means the triangle must be isosceles. That means these legs have to be congruent. So it goes both ways. Okay, so basically the way you kind of want to think about it is if you have these angles marked at the bottom, the sides that are right above them, right? They're connected, right? So if the base angles are the same, then that means the legs are the same. If the legs are the same, then that means the base angles are the same. Okay. All right, so let's take a look at this first example right here, okay, which says find x, which is out here. Okay, so I have a couple of different ways that I could do this, right? But I could use the triangle sum theorem, or I could use the exterior angle theorem because x is an exterior angle. Okay, but first I have to figure out what these base angles are, right? So notice that these angles at the bottom are marked with congruent symbols. So that means this is an isosceles triangle. I have these two legs here that are congruent, okay? And these two base angles are congruent. So what I'm gonna do is I'm gonna call them like B. It does not look like a B. So I'm gonna call these both B for base angle, okay? I know that in this triangle, okay, all three of these angles, 44, B, and B, have to add up to 180 because that's the triangle sum theorem, okay? Right? So I have B plus B, which is 2B, plus 44 equals 180. So I'm going to go through and subtract 44. So I get that 2B is equal to 136. And then I need to divide that in half, right? Divide by 2, divide by 2. So I end up with B is equal to, let me see if I can do this in my head, okay, that B is equal to 68 degrees. Okay, so what that means is that both of these angles at the bottom are both 68 degrees. Okay, so this is 68 and this is 68. Okay, so now I have two ways that I could figure out what x is. I could do 44 plus 68 because those are the remote interior angles, right? So that would be using the exterior angle theorem, right? So I could do it that way, which I'll kind of mark in green for you here, right? So I could do it that way and say x equals 44 plus 68, okay? So x is equal to 112, okay? Or I could say, well, 68 and x have to form a straight line. So I could do x plus 68 equals 180 and subtract, and I still end up with x is equal to 112. Okay, so either way, you get the same answer, right? So use whichever one like works for you or makes the most sense for you, okay? But where we use the isosceles triangle idea and theorem is here in this first part, right? So if you are given the vertex angle and have to find the base angles, you always do 2 times the base angle plus the vertex angle equals 180. okay? If you're trying to find the vertex angle and you're only given one base angle, for example, you would still do 2 times the base angle plus the vertex angle that you don't know equals 180, okay? So the general formula here is 2 times the base angle plus the vertex angle has to equal 180, okay? It's just depending on the problem. Sometimes they'll give you the base angle, sometimes they'll give you the vertex angle and ask you to solve for something that's missing, okay? All right, let's take a look at example 2, where I have to find x, okay? So I have a lot of information here, right? And I'm gonna have to go through this and do this in a couple of steps, right? Because I only have one number. I only know that the vertex angle of this kind of fatter triangle, the one that almost looks like an equilateral triangle, has to be, this one is isosceles because you have the 2 congruence marks on there. So I can use that to find my base angles, right? So I have 2 times my base angles, right? B and B plus 56 has to equal 180. Okay, so I end up with 2b equals 124, and then I'm going to cut that in half and get that b, that base angle, is equal to 62. Okay, so this angle here is 62, which is going to help me, okay, because now I have this second isosceles triangle. See it with the 2 congruence markers, one right here and one right here, right? And then x down here is the base angle of this isosceles triangle. It's kind of tipped on its side. So I need to figure out what the vertex angle is first, right? I got to know what this vertex angle is. Well, I know that this vertex angle, which is marked with a question mark, plus 62 has to equal 180 because they form a straight line. See down here at the bottom? Okay, so that means that that angle, that question mark angle, is 118. Okay, all right, so now, okay, now I can use that to find x. So 2 times x, right, because technically this angle up here is also x, 2 times the base angle plus 118 equals 180. Okay, so I end up with 2x equals 62 again, right? And cut that in half, divided by 2, divided by 2. So you get that x is equal to 31. Now I'm hoping that you noticed, okay, that what you end up with here is this. Okay, that's not always going to be the case, but I could have gone through and like skipped this solving for the question mark one. If I wanted to, I could have, because you end up with the same thing, but that's only because it's only because you're dealing with 2 isosceles triangles here, and that you have lots of these sides that are congruent. All right. Okay, you guys, so that is it for the triangle theorems. Those are your 5 triangle theorems. Like I said, I hope that a lot of these at least seemed familiar to you, but now you've gotten to see like some examples of how these problems might come up and arise. Okay, so in the next video, I've got some more practice problems for you. But if you're feeling good from here, then I would go ahead and try the practice that goes with the online practice that goes with this section, right? So I will see you in the next video. Bye, everybody.